Welcome to your lesson on section 5.4, where we're taking a look at head-on collisions. And we start by defining what a perfectly elastic head-on collision is. And in section 5.4, we are looking at this in one dimension. A perfectly elastic head-on collision occurs when two objects approach from opposite directions. In a perfectly elastic head-on collision, after the collision, both momentum and kinetic energy are conserved. Due to this fact that both momentum and kinetic energy are conserved, through algebraic manipulation, we have derived, or we can derive, the final velocities for both objects. There is a huge, long derivation process that we can go through to calculate the final velocities. For the purpose of this course, however, we do not need to worry about doing this. I'm just going to give you the equations that we follow. And let us first see the first equation that's important for head-on collisions. The final velocity of object 1, through this derivation, we get a fairly intensive formula where we have m1 minus m2 over m1 plus m2 multiplied by vi1, and that will be added to two m2 over m1 plus m2, and that is multiplied with our vi2. And do remember, these velocities are all vector quantities, so direction is important. That's to calculate the final velocity of the first object. The final velocity of the second object will therefore, again, if we were to manipulate the algebraic expressions, again, you do not need to memorize these formulas for tests. You are allowed to use them. Very similar to VF1, however, we do have a few slight differences, but there is our equation if we need to calculate the final velocity of the second object as well. And that's really all that this example that I'm about to show you is going to be. It's going to be calculating the final velocity of both objects in a perfectly elastic head-on collision. In which we have a 300-gram toy train involved in an elastic collision straight on with a 600-gram toy train. The 300-gram train is moving at 2 meters per second, and our 600-gram train was at rest. Let us determine the final velocity of both trains after the collision. We're going to assume in this case that train 1, and that's the 300-gram train, was moving forward. We're going to assume this because we can set a direction as positive, and we can say that forward is our positive direction. That is our assumption that we shall make. And given in the question we have mass of this first train, and that's going to be 300 grams, which we divide by 1,000 to put it into kilograms. And that train is initially moving in the forward direction at 2 meters per second. The second toy train we will call toy 2, and its mass is 600 grams, which we again divide by 1,000 to get us 0.6 kilograms. And I should have put VI1 up there because VI2 is 0 meters per second. So we shall calculate the final velocity of the first train, the 300-gram train, and the final velocity of the second train, and that is the 600-gram train, to see what we get. And we use both of those final velocity equations basically. So let us first calculate VF1. And I'm noticing that my video might be paused, so I'm going to stop it and add a second video just in case.